Imagine an F-35 that doesn't carry 4 missiles, but 20. Not in theory, not on paper. In real combat, this isn't about speed. It's not about stealth. It's about something far more dangerous, running the enemy out of options. Because when every American fighter carries 5 times more weapons than expected, numerical advantage stops mattering, and air superiority becomes inevitable. This is the Raytheon Peregrine, the smallest U.S. missile ever built, and the reason future air battles won't be decided by who has more jets, but by who runs out of missiles first. 6 feet long, 150 pounds, half the size of the missile it's replacing. And an F-35 carrying Peregrine could launch up to 20 air-to-air missiles in a single sortie, compared to the 4 it carries now. That's not incremental improvement. That's a complete reimagining of how stealth fighters engage in air combat. And what makes this tiny missile truly terrifying is that it combines AMRAAM's range with Sidewinder's maneuverability in a package so small that adversaries face an impossible problem. Every American fighter suddenly carries 5 times more weapons than intelligence assessments predicted. This is the Raytheon Peregrine, the smallest medium-range air-to-air missile the United States has ever built. And size isn't a compromise, it's the entire point. Because in modern air combat, magazine depth determines who wins extended engagements. And when Chinese J-20s carry 6 missiles, while American F-35s carry 20, the mathematics of attrition warfare shifts so dramatically that numerical advantages become irrelevant. Let me show you why smaller is deadlier, and how this missile solves problems the Air Force didn't even publicly admit existed. The foundation is magazine depth, a concept most people never think about, but one that determines survival in contested airspace. Current F-35As and F-35Cs can carry 4 AMRAAMs internally. The F-22 Raptor carries 6 in its main weapons bay. Those numbers sound adequate until you consider realistic combat scenarios. An F-35 encounters 8 enemy aircraft. It fires all 4 missiles, achieving hypothetical kills on 4 targets. The remaining 4 enemy aircraft are still closing, and the F-35 has no more weapons. It must retreat or switch to external hardpoints, compromising stealth. Peregrine solves this by doubling or tripling magazine capacity without any major modifications to existing aircraft. At approximately 6 feet long and 150 pounds, the missile is roughly half the size and weight of the AIM-120 AMRAAM, which measures 12 feet long and weighs 335 pounds. On 4th or 5th generation fighters, you can double or triple the loadout. You can at least double the loadout on an F-35. Think about what that means tactically. An F-35 currently carries 4 AMRAAMs. With Peregrine, it carries 8 internally, potentially more with weapons bay modifications like Lockheed Martin's Sidekick adapter, which already increases AMRAAM capacity to 6. If Sidekick works with Peregrine's smaller dimensions, the F-35 could carry 12 Peregrines internally. And Lockheed Martin has teased a notional beast mode for the F-35 carrying 16 AMRAAM and Sidewinder missiles externally. With Peregrine, it might carry up to 20 missiles total. 20 missiles, 1 aircraft, that's not a fighter anymore. That's a flying magazine that can engage an entire enemy squadron without reloading. And it fundamentally changes how air combat unfolds, because adversaries cannot predict American loadouts based on observable aircraft numbers. 2 F-35s don't represent 8 missiles. They represent 40. But raw capacity is meaningless if the smaller missile sacrifices performance. And this is where Peregrine becomes genuinely revolutionary. It doesn't trade capability for size. Raytheon states it combines the range and autonomy of the AMRAAM with the maneuverability characteristics of the AIM-9X, with extreme maneuverability as it approaches its target. That's not marketing. That's engineering achievement, compressing 2 different weapon systems into one platform half the size. The propulsion section is described as a new, high-performance system that gives a missile half the size of AMRAAM, a range that Raytheon declines to specify, but characterizes as beyond medium range. Read between those lines. If AMRAAM reaches 100 miles, and Peregrine is described as having greater range despite being half the size, the engineering breakthrough in propulsion is substantial. Likely solid fuel formulations with higher energy density, more efficient nozzle designs, and optimized burn profiles that extract maximum velocity from minimal mass. The missile gains its maneuverability through thrust vectoring technology similar to what is used on the AIM-9X. Thrust vectoring means the rocket nozzle can change direction during flight, allowing the missile to execute turns that aerodynamic controls alone cannot achieve. This enables intercepts against targets pulling high-G evasive maneuvers, targets flying perpendicular to the missile's approach, and targets attempting last-second defensive brakes. Traditional missiles without thrust vectoring rely solely on fins and control surfaces, limiting maximum turn rates. Peregrine can literally steer its thrust, creating maneuverability that matches or exceeds the AIM-9X, despite having medium-range flight profiles. The guidance system is a multi-mode autonomous seeker that includes infrared imaging combined with other sensor types. Raytheon declines to specify. Multi-mode means the missile switches between guidance methods based on conditions. Active radar homing works in most weather, but can be jammed. Infrared tracking is passive and immune to electronic warfare, but requires line of sight and clear atmospheric conditions. A multi-mode seeker uses whichever method works best at any given moment, ensuring track continuity regardless of what countermeasures the target deploys. The sophistication packed into that miniaturized guidance system represents decades of sensor development compressed into a package measuring inches across. Miniaturized ASA radar elements, cooled infrared focal plane arrays, digital signal processing, and autonomous tracking algorithms, all integrated into a seeker head that weighs a fraction of legacy systems while providing superior performance. The missile can detect and track targets at any time of day and in any weather condition, maintaining lock through clouds, smoke, chaff, and jamming that would defeat older weapons. The warhead is described as blast fragmentation, designed to down enemy aircraft through explosive force and shrapnel rather than direct kinetic impact. This is critical for a small missile. Larger missiles like AMRAAM rely partly on kinetic energy from their mass at impact. Peregrine has less mass, so the warhead must compensate with more efficient explosive design. Modern blast fragmentation warheads use shape charges and directional fragmentation patterns that concentrate destructive force toward the target rather than wasting energy in all directions. The result is a warhead that achieves equivalent lethality despite smaller overall size. Cost is the final advantage, and it might be the most strategically important. The missile is half the size and cost of today's air-to-air missiles. Raytheon states Peregrine will cost significantly less to buy and maintain than the AIM-120 or AIM-9X, enabled by off-the-shelf components and additive manufacturing. Traditional aerospace manufacturing requires extensive tooling, machining, and assembly. Additive manufacturing, 3D printing of metal components, eliminates much of that overhead. Parts that previously required months to machine can be printed in days. Complex internal geometries impossible with traditional methods become feasible with additive processes. Lower costs mean the military can afford larger stockpiles. The United States fired thousands of missiles during operations in Iraq and Afghanistan. Future conflicts against peer adversaries like China could consume even more. If Peregrine costs half what AMRAAM costs, the military can procure twice as many missiles for the same budget, or maintain equivalent inventory sizes while freeing billions for other programs. Either way, affordability multiplies combat power by ensuring adequate munitions are available when needed. But here's the strategic implication adversaries are scrambling to counter. Peregrine doesn't just increase magazine depth, it fundamentally changes the economics of air combat. Currently, shooting down an F-35 requires overwhelming it with multiple threats before it expends its 4 missiles. With Peregrine, that F-35 carries 8, 12, maybe 20 missiles. The attrition calculus collapses. China cannot afford to lose 20 J-20s, eliminating 1 F-35. Russia cannot sustain a conflict where every American fighter requires an entire squadron to defeat. And the timeline matters. Raytheon unveiled Peregrine publicly in September 2019 at the Air Force Association's National Conference. The weapon is presently an internally funded project, meaning Raytheon is developing it with company resources rather than government contracts. The plan is to offer it as a complement to the AIM-120 and AIM-9X. This is strategic. By self-funding development, Raytheon maintains flexibility to tailor the weapon based on military feedback without being locked into rigid contract requirements. The Air Force showed renewed interest in small air-to-air missiles in May 2025, releasing a request for information seeking industry input on developing missiles half the size of AMRAAM. That RFI specifically cited concerns around magazine depth and the ability to affordably scale production to meet demands of future conflicts. The crew of at least one F-15E was forced to switch to guns after running out of missiles while responding to Iran's missile and drone barrage in April 2024, but was unsuccessful in bringing anything down. That incident underscored the magazine depth problem. Modern fighters face threats in quantities their weapons loadouts weren't designed to handle. Peregrine addresses this directly. Instead of developing entirely new aircraft with larger weapons bays or accepting stealth compromises from external carriage, the military can double or triple existing capacity by simply integrating a smaller missile. The F-22, F-35, F-15, F-16, and FA-18 all carry Peregrine on existing hardpoints and launch rails. Integration costs are minimal compared to developing new platforms. And legacy fourth-generation fighters suddenly gain magazine advantages they've never had, extending their operational relevance by years. International implications are significant. United States allies operating F-35s face the same magazine depth constraints American forces do. Australia, Japan, South Korea, and European partners all field small F-35 fleets, where magazine capacity directly limits combat effectiveness. Peregrine enables those nations to dramatically increase firepower without procuring additional aircraft, making their existing investments far more capable at relatively low cost. The name itself reveals the weapon's nature. The Peregrine Falcon is nature's fastest bird, capable of diving at speeds exceeding 200 miles per hour to strike prey mid-flight. The Falcon doesn't rely on size. It relies on speed, agility, and precision. Raytheon chose that name deliberately. This missile represents the same philosophy: small, fast, maneuverable, and absolutely lethal when it strikes. The smallest United States missile ever built isn't a compromise forced by budget constraints or technical limitations. It's a deliberate strategic choice to maximize magazine depth, reduce costs, and fundamentally alter the mathematics of air combat in America's favor. When adversaries plan engagements against F-35s, they calculate based on 4 missiles per aircraft. Peregrine makes those calculations obsolete overnight. And by the time enemies adjust their doctrine and tactics, American fighters will already be carrying weapons loads that make numerical parity irrelevant. Size isn't a weakness, it's a weapon. And 20 missiles on one fighter is deadlier than any adversary is prepared to handle.